Hello everyone, this is Sabir Ocean. Welcome to ArcGIS class 9 for beginners. Today we'll discuss about how to do flood level analysis in GIS. So at first open ArcMap. So at first add dam and fault line. Now open water level spot value at Excel. Now copy in the values and paste it another sheet as paste values. Rename the selected cell anything like coordinates cell. Uh, and now save it. Uh, and save test type Excel 1972 2003 workbook. And okay. Now add the Excel file. Right click on it. Display XY data. Give the values like easting as X field or northing as the Y field and water level meter in Z field, and add the coordinate system BTM. Then click OK. Now we will change the coordinate points into shapefile because it's a temporary file. If we close the ArcMap for the next time, we will again have to work on those Excel file, then show XY data and so on. But if we change it into shapefile, we will be able to work on it further. So right click on it and go to data, then export data. Select the directory and the name. And click on OK. Now we can remove the other layers of coordinate. As we know, only the water level of the some certain point, but know the whole area. We have to interpolate it to predict or assume a surface where flood occurs or not. So go to Arc Toolbox. Then click on 3D Analyze tool and raster interpolation. The raster interpolation. What is raster interpolation? Raster interpolation to create a continuous surface from sampled point values, visiting every location in a study area to measure the height, concentration or magnitude of a phenomenon is usually difficult or expensive. Now click on IDW. IDW is interpolation explicitly makes the assumption that things that are close to one another or more alike that are further apart. To predict a value for any unmeasured location, IDW uses the measured values surrounding the prediction location. The measured values closest to the prediction location have more influence on the predicted value than those further away. IDW assumes that each measured point has a local influence that diminishes with distance. It gives greater weights to points closest to the prediction location, and the weights diminish as a function of distance. Hence, the name inverse distance weighted. So click on IDW and input point feature as water level point, and select the Z value as shape Z. Choose the directory and file name, rename it. Now as the cell size of them is 300, here select 300. Now give barrier as fault line and then click on environment. Processing extent same as the DEM. Snap raster also same as the DEM. Then click on raster analysis, and here cell size are same as the DEM meter and marks is also same as the meter. Then click on OK and OK. So go to Word file and see what is the first question. Generate flood map and classify flood as per the FFWC category. So for this, go to raster analysis, then go click on interpolation, then click on math algebra and then raster calculator. And now we know water level equals to RL or dam plus inundation. So inundation equal water level minus dam. So at first double click on water level IWD minus dam and select the directory and rename it. Then click OK. Now go to the properties of inundation and click on classified and select the classes 6 and click on classify. Now input the values like from downward 3.6, 1.8, 0.9, 0.3 and last value is 0, which means flood free. Now if we change the color, I want to this selection and then click OK. So here is our first question answer. Now go to second question. Here find out the flood statistics for each category. For this, reclass the inundation. So here is plus. Click on reclassify and then select the input raster as inundation. Okay. Then as if before classify the inundation, so here uh, there are, then click on output raster and select that reclass. Done. Then click OK. So go to the inundation, open up to table and calculate the and add calculate the area. For this, add field and area and see that in kilometer, square kilometer. So square kilometer. Then click plot 10. Then click OK. Now go right click on the area square kilometer and click on right click field calculator. Yes, and then double click on count value and multiply by 900 because our cell size are 300 into 300. So multiply by 900 and divided by 10 to the power 6. Click on OK. And now add another add field. Then write percentage. Then click plot. At first see the sum of the area square kilometer and copy it. Then field calculator divided by the sum of the area square kilometer and multiply by 100. And click on OK. Here you see the percentage of the value. If the value is 1 2 3 4 5 6, which not means we cannot understand what is it. So you can identify and that our flood free equals to f0, flood free flood 1 equals to f1. So go to add field and add field and status, then text type. Okay. Here we go to field calculator, then in inverted f and click on ampersand and double click on value. So here you see that f1 means flood free, f2 means flood 1 level. So this is the our final question answer, second question answer. So go to third question. Third question is identify the extent or magnitude of flood for each thana and generate statistics. For this, at first add the Thana boundary. Okay. Go to shapefile, then click on Thana boundary. So here is the Thana boundary. Now oh, now intersect inundation reclass and Thana boundary. As we know, inundation reclass is a raster file, so there is no polygon here. So at first convert the inundation reclass to polygon. So in search option, right, click on raster to polygon. Double click on it, and inundation reclass and select the directory bar. So I want to raster for click on OK. Now intersect the raster to poly and Thana boundary. Select the directory output feature class, rename it raster poly with Thana boundary. Then click on OK. Now go to open attribute table and find the area of the flood 1, flood 2. For this, add field name area flood category, and here is plot 15 6. Now calculate geometry in kilometer. Click on OK. Here is our area. So now copy the all values and go to Excel file. Now go to insert and click pivot table. Click OK. Then Thana name as row, area FC as values, and read code as column. So here is the total answer. So we see that in column total. So, this is our third question answer. Now go to our fourth question. Fourth question is show settlement under various flood categories. For this, go to ArcMap and at first unselect them. and add the BGD settlement 2013. Now intersect the BGD settlement and raster to poly. Click OK. Now go to BGD raster poly, open attribute table, and select the all open attribute the file and click OK. Copy selected. Go to Excel file, open sheet, another sheet, and paste it. Now go insert and click on pivot table. Now for the question fit code as row or column and type as row and also type as values. So here is our fourth question answer. Now discuss about how to create a map of East Thana. For this, at first click on Thana boundary symbology and add just boundary Thana and show the Thana name. For this, go to label, then click on label of and label field as Thana name and click OK. And also select the inundation. And now click on layout view and change the page and feed setup. I select A4, click on landscape, then OK. And if you want to know, then click guideline. And I want to add an index map, so go to insert and click on data frame and drag the Thana boundary in the new data frame. I see the index map. reshape it. If you don't show the Thana name, so for this, go to properties of Thana boundary and unselect the label feature in there. And now I want to add a title, Upazila Thana map. And if we font size change, then go to its properties and change the symbol. And font size selected. Click OK. Okay, and now click on new data frame and go to its properties. Then select the layers and click on it and click use simple extents and click frame. If you want to change the color of border, then you can change it from them. I cannot change it, so click on OK and then apply. So go to Thana boundary and click on open attribute table and double click on any Thana. Here we see that our Thana, and if we say change the boundary line and change it, change and now if we add the Thana name or any other, then right click on the windows and select the data driven page. Then go to data driven page setup and enable it and layer option and then OK. Now we see the Thana boundary and here we take our Thana. And if you add Thana name, then say add it and also change the font size. So I want to change it. And go to its position. And then go to file option and click on export map. Select PDF and resolution minimum 300 and go to page option and then click all 72,000 page, 72 page, because our Thana are 72. So select the all page and then uh, rename it. Click OK. Now go to the file location where we export the map and open the map. So this is our map, Thana map, and here we see the all 72 Thana are here. So this is for today, guys. Thank you for watching. Goodbye.